All right, now in this example, we're given the following chart of numbers and the rules for what we'll call clock addition, which is a type of addition that circles back in on itself. So instead of continuing indefinitely, there comes a certain point where when you add, you recycle, you start over. Much like time. If it's 11 o'clock in the morning and 2 hours pass, you don't say that it's 13 o'clock outside of military time, but you would say that it is 1 o'clock. Why? Because it circles back on itself every 12 hours. So you go 11, 12, 1, and then you repeat that over and over. This is very similar where once we reach 3, if we do 3 plus 1, we reset down to 0. 3 plus 2 would be 3, 0, and then 1, and so that's why it's called clock addition. Now, in this particular example, we're asked to verify that it obeys the associative property, or in other words, that the order in which I add things does not matter. And so how do we verify that? Well, we add them in different orders and see if it works. So over here, if I do 1 clock addition 2, 1 plus 2, that's 3. So this becomes 3 clock addition 3. And then down here, 3 clock addition 3. Okay, so 3 plus 3 is 2. Let's see if we get the same thing over here on the right-hand side. So instead of doing the 1 with the 2 first, we're going to do the 2 with the 3 first. So 2 o'clock, add 3 hours on this weird 4 clock system. 2 plus 3 is 1. So I have 1 clock addition 1. And now we do 1 clock addition 1. 1 o'clock plus 1 more hour, 2 o'clock. And so notice, doing them completely independently from each other, we wound up with 2 in both cases. So this is a verification of the associative property being obeyed by this clock addition. And that is this example.